All right, here's page 2 of my log rules worksheet. I got my log rules and identities and change of base formula all written up here that I might reference as I go on. I already did the first page in a different video. In the second page, we start out with these kind of expanding of logs. First page was more contracting logs. So you have this big mess, and you're asked to break it up into a bunch of different logs, specifically write it in this form right here. Well, we can do that. I could first say that this is equal to the log. See, I guess using my second log rule, I have the log of something divided by something. So that's the same as the log of the top, 8x cubed y to the fourth, minus the log of the bottom, which is 2000 z to the third power. And from that I want to subtract. Should I do it now? Yeah, I'll do it now. The square root of something is the same as raising it to the 1/2 power. And I can use my third log rule to bring that 1/2 down in front and call it the log of 2x. Just like I did there, I can take care of this square root. I can bring this square root down in front and call this 1/2 times the log of 8x cubed y to the fourth. Minus, you might want to bring this 3 down, but you can't. The reason you can is the entire thing is not being cubed, only the z is being cubed. So I guess what I could do is I could subtract off, and then I could use my first log rule. I have the log of something times something else, so I can rewrite that as the log of 2000 plus the log of z to the third power minus 1/2. And again, I got the log of something times something, so I guess I could rewrite that as the log of 2 plus the log of x. Breaking this down into as many pieces as possible. This first one, I really haven't broken that down. The log of something times something times something. So I got the log of 8 plus the log of x cubed, which hopefully it's okay for me to do 2 steps there. First, I'm breaking this up into 3 different logs, so adding. And then while I'm here, I'm also bringing the exponent down in front of their respective logs, so I get something that looks like this. And then I can take this negative and distribute it through, so I get my, well, I'll do that in the next step. Log 2000 plus log, plus, maybe I'll bring that exponent down while I'm here, plus 3 times the log of z. And here there's not a whole lot I can do except for distribute that 1/2. I'm going to do that in the next step. So I'm just going to go ahead and rewrite all that. I think I've broken the logs down about as far as I can, so now I'm just going to distribute these coefficients and combine like terms. So I got 1/2 the log of 8 plus 3/2 log of x plus 2 log of y. I'm going to take this negative and distribute it through minus the log of 2000 minus 3 times the log of z. I'll take this negative 1/2 and distribute it through minus 1/2 times the log of 2 minus 1/2 times the log of x. Now maybe I can combine like terms. Let's see, it wants my x's first. So I got 3/2 log of x and minus 1/2 log of x. So I just have 1 log of x. I took care of this term and that term. Maybe I won't underline them, that might get ugly. What about my y's? Well, this term has a log of y, and I believe that's the only one. So I got plus 2 log of y. What about your z's? Well, there's some z's here and here. I think that's all of them. Yeah. Oh, that's a 2 actually. That's not a z. So this is my only z right here. So I got minus 3 log z. Now I just need to figure out my constant terms. Let's say I have minus 1/2 log 2. Any others? Here we go. Minus the log of 2000. And I have plus 1/2 log 8. So I'm almost done, although the problem kind of implies that d should be a whole number. So let's see if we can make that work. Let's take all this stuff here. Maybe come work on it up here. Let's see, this I could rewrite as, I could bring that 2 back up into the exponent, so I got the log of 2 to the negative 1/2 power plus the log of 2,000 to the negative 1 power plus the log of 8 to the 1/2 power. And I can mash those all together to call it the log of 8 to the 1/2 up on the top. And then 2 to the negative 1/2 is the same. How about I'm going to write that as the square root of 8 so it's easier to look at. Instead of 8 to the 1/2, square root of 8. And then 2 to the negative 1/2 is 1 over the square root of 2. And 2,000 to the negative 1 power is 1 over 2,000, which gives me something that looks like this. Root 8 over root 2 is root 4. And root 4 is just 2. So this is the log of 2 over 2,000. And 2 over 2,000, same as 1 over 1,000. And log of 1 over 1,000 is asking you what power does 10 need to be raised to make it 1 over 1,000. Well, negative 3 will do the trick. So this whole thing's equal to negative 3. So my final answer, I don't know where I'm going to squeeze it in, would be all this same stuff. 1 log x plus 2 log y minus 3 log z minus 3. And it looks like A, B, C, and D are all either negative 3, negative 2, negative 1, 1, 2, or 3. Looks like that satisfied that criteria, so hopefully I didn't mess anything else up. Okay, part B here, it's actually a lot like part A, so I don't know, I'm not thrilled to do it again, but if I put it on here, I should do it. The first thing to note is that I'm taking the log of the square root of a whole bunch of stuff. And the square root of a whole bunch of stuff is the same as a whole bunch of stuff to the 1/2 power. So really, what I can do is pretend this is all raised to the 1/2 exponent, and using my third log rule, bring that down in front. So I got 1/2 times a whole bunch of stuff. The log of this divided by this. But wait a minute, this divided by this, if you have the log of something divided by something else, you can use the second log rule. So I'm kind of doing 2 steps in one here, to rewrite this as the log of 2x squared, y to the 1/3 power. So the cube root is the same as the 1/3 power, minus the log of 20z cubed. So that takes me here. And careful, the 1/2 has to hit the entire thing. Now what I'm going to do is apply my first log rule, because I have something 2 times something else x squared times something else y to the 1/3. And I'm going to do it on both of these. So I'm going to do it on these 3 factors and on these 2 factors. So I got 1/2 times a whole lot of stuff. That stuff is the log of 2 plus the log of x squared. I think we're at the point in the worksheet where I can do 2 steps at once. The log of x squared is the same as 2 log x. The log of y to the 1/3 power is the same as 1/3 log of y. And I'll close those parentheses. Let's see, I'll have to be a little bit careful here. That was the stuff that was on the top. And from that, I want to subtract. And on the bottom, I got the log of 20 plus 3 times the log of z. Okay, now I guess I can distribute stuff through. So I take this 1/2, and that's got to hit these 3 terms and these guys. 1/2 hits everything. But this negative also has to hit these guys here. So what that gives me when the dust settles is I get 1/2 log, what is that, a 2? Plus 1/2 times 2 is just 1. So I got 1 log x. Plus 1/2 times 1/3 is 1/6 log y. 1/2 times log 20 would be 1/2 log 20, but I got the negative also to deal with. So I have minus 1/2 log 20. And then I have the 1/2, the negative, and the 3 gives me minus 3/2 log z. Any like terms here? Here's my only x, here's my only y, here's my only z. So I guess what I have to deal with is just the constant terms again. I got log x plus 1/6 log y. Minus 1/2, minus 3/2 log z. And then the question becomes, what about the constant term? Maybe I can do that off on the side again. 1/2 log 2 minus 1/2 log 20. Well, I can bring that 1/2 up and make that the log of 2 to the 1/2 power, aka the square root of 2. And I'm going to keep that as minus and call this the log of the square root of 20, taking those 1/2s up. And then using my second log rule, I can say this is the log of this minus this becomes the log of root 2 over root 20, which is the square root of 2 over 20. And that is the log of the square root of 1/10. And so that's asking me what power must you raise 10 to make it equal to the square root of 1/10. Well, the answer to that question is negative 1/2. So that goes over here. And I'm finally done with that mess of a problem. A couple more at the end here. I think, fortunately, these will go a little bit quicker. Preview into what we will be seeing next in our class. These are log equations. So solve this equation for x. Get the x all by itself. How are you going to do that? Well, it's kind of buried in here, but I can uncover it. I could first add 5 to both sides of the equation. Gets me here. And I can divide both sides of the equation by 2. And then you're kind of stuck, maybe. What I want to do is get to this x, but it's inside a log. How do you deal with that? Well, there's 2 ways. This is logarithmic form. You can rewrite it in exponential form. You might know that this statement is the same as 3 to the second power equals 4x plus 1. More advanced way to do it is do 3 to both sides of the equation. 3 to all this stuff is just equal to 4x plus 1. 3 to this side of the equation would be 3 squared, which is 9. Subtract 1 from both sides of the equation, you got 4x equals 8, and therefore you got x equals 2. Last problem, similar. I got an x, it's just hidden inside a whole bunch of junk. If I can deal with it, add 5 to both sides. 2 log base 3 of something, 4 to the 3x minus 1 plus 17 equals 8. If I add 5 to both sides, now take care of this too. Divide both sides by 2. Log base 3 of all that junk, 4 to the 3x minus 1 power plus 17 equals 4. Now, same thing. I got to get rid of a log base 3 like I did down here. The way I prefer to do it is do 3 to both sides of the equation. The 3 is a base, and the log base 3 up in the exponent cancel each other out. I'm left with 4 to the 3x minus 1 power plus 17 equals 3 to the 4th power. Turns out 3 to the 4th power is 81, because 3 times 3 is 9, times 3 again is 27, times 3 again gets you 81. So now if I subtract 17 from both sides of the equation, I get 4 to the 3x minus 1 power is equal to 81 minus 17, 64, I believe. So now I'm going to take the log base 4 of both sides of the equation to get 3x minus 1 is equal to log base 4 of 64. Well, the log base 4 of 64 is asking me what power does 4 need to be raised to make it 64. Turns out 4 cubed is 64. 4 times 4 is 16, times 4 again is 64. So I get 3x minus 1 equals 3. Add 1 to both sides, you get 3x equals 4. Divide both sides by 3, and you're done. You get x equals 4/3 here. Whew, all right, I am happy to be done with this.